Dear friends, welcome to my YouTube channel, Mathematics and Statistics Pruning, a channel dedicated to the service related to teaching learning activities in mathematics and statistics. This is Indra Vichapri here, a career educator. People love to address me as Dr. K. Today in this video, we shall try to explore the normal distribution, a popular and widely used continuous probability distribution in statistics. Here, we shall focus our discussion mainly on how to calculate probability in terms of area in an interval under the normal curve.
Normal distribution, also known as Gaussian distribution, is a widely used probability distribution in statistics. It's a continuous probability distribution of a random variable x with mean mu and standard deviation sigma. The parameter of this distribution is mean mu and standard deviation sigma. This symbolic representation of this distribution denotes the random variable x follows normal distribution with mean mu and variance sigma squared. Graphically, this distribution is displayed in the form of a symmetric bell-shaped curve around its mean, which is defined by this function, satisfying the following properties. This line at the center point is the line of symmetry. Almost all the data points clustered around the mean, that is at the center of the distribution. Very few data points fall along the tails of the distribution. Mean, median, and mode of this distribution are equal and lie at this center point. This distribution is completely defined by mean mu and standard deviation sigma. That is, if we know mean and standard deviation, this curve can be generated using this function. The total area under the curve is 1. This property is used to find the probability in terms of area, which is defined only in an interval. Therefore, the point probability is 0 for this distribution. That is, at any point x equals a, the probability of this event is 0. Hence, the probability of this event x less than or equal to a is same as the probability of this event x strictly less than a. This complicated function can be simplified to a simple one using this standard transformation that transfers the random variable x into g-score, and the complicated function takes this form with mean 0 and standard deviation 1, and popularly known as standard normal distribution. The table is available for computing the probability for this standard normal distribution.
Next, let's start computing the probabilities for standard normal distribution or Z distribution using Z table and then other utilities. Other general distributions with mean mu and standard deviation sigma also can be converted to Z distribution by using this standard transformation, and then we can use Z table for computing probabilities.
Now we shall discuss how to compute left tail probability, that is probability g less than a certain value a, this area, right tail probability, that is g score greater than certain value b, this area, and the middle probability, that is g score falling in an interval ab,
this shaded area. As an example, we shall compute this left tail probability, that is g score less than negative 1.75. This probability g score greater than 1.48, right tail probability, and this probability is G-score lying between negative 1.42 to 0.96, the middle probability.
We shall use these methods, Z-table, statistical computing software, or Excel, TI calculator, and my website www.teachyoumath.com for computing these probabilities. Among these methods, I think my website at this link would be the easiest one to start with. Let's get to this page. This is the page. Here we see that two radio buttons are selected by default. Keep this one as it is, and this one is for self-generation of probabilities. If we refresh it, we can see that generation of different probabilities for different distribution here in the display panel. Since we are in the process of computing probability manually, so we should select this button, normal table manual. Also, we are working with standard normal distribution. So let's keep this mean 0 and standard deviation default values as it is. And on tail choices, let's go with the default left tail. And then change the lower value 8 to negative 1.75. The result, the left tail probability 0.04006 is printed on the display panel, which is this area. This is the left tail probability. Now to compute right tail probability with all this default value as it is, in the tail choices, we select upper tail and then change this upper value 12 to 1.48. We see that the result right tail probability 0.06944 is printed on the display panel, which is this shaded area. And last, for middle probability, in tail choices, we select middle and replace this value on lower tail by negative 1.42, upper tail by 0.96. We see the change in the result on the display panel. The probability 0.7537 is the middle probability equivalent to this shaded area. This is how we can compute probability of a standard normal distribution using my website.
Now let's discuss the use of some technologies such as R, Excel, and TI calculator in computing these normal probabilities. First with R. The command is pnorm with the argument inside the parenthesis, G-score, mean, standard deviation, lower tail 2, and log option. Consider the left tail. Pnorm is the full command, but in the present case, we shall replace this first command Q by the G-score value negative 1.75. The other default arguments remain as it is. If we type this command at the R console and enter, we get this result, left tail probability corresponding to Z-score negative 1.75. Next, consider the right tail. We use the same command pnorm here, but with slight change with lower tail equals false. Replace Q with G-score 1.48 and the argument lower tail should be changed to lower tail false because we are computing right tail probability, not to the left. Other default argument like mean, standard deviation remains same. If you type this command at the R console and enter, we'll get this result, which is the right tail probability. Now let's proceed to compute middle probability with this example, probability of G-score lying between negative 1.42 to 0.96, which is the area between negative 1.42 and 0.96 as shown in this figure. Notice here that this interval, which is the area in between negative 1.42 and 0.96 as shown in this figure, splits into these two left tail probabilities, first with z-score less than 0.96 and the second, this z-score value less than negative 1.42. This middle tail probability is the difference of these two left tail probabilities and computed as the difference of these two p-norms. That is p norm 0.96 minus p norm negative 1.42. If we copy this command and paste at our console and enter, we get this value as the middle probability. Let's go with Excel to find these probabilities. The command is norm.dist. Inside the parenthesis, the arguments are value, mean, SD, and true. This true logical argument for cumulative probability. Let's start with the left tail probability. The command normdist with arguments g-score, mean, standard deviation, and true. If we copy this command and paste in any cell of Excel, we get this left tail probability. We compute right tail probability as a complement to the left tail probability as 1 minus the left tail probability. If we copy this command and paste in any cell of the Excel worksheet, we get this right tail probability. We compute middle probability as the difference of two left tail probabilities as given here. If we copy this command and paste in any cell of Excel, we get this value, which is the middle probability. Regarding TI calculator, to compute these probabilities, we first press two buttons, second and verse, on the calculator. That leads to a screen containing the menu items. From this menu option, we select two normal CDF and enter. That takes us to a screen where we input our information, such as lower, upper, mean, and standard deviation. For the left tail, the lower is negative 1 E99, a very high negative value representing negative infinity. Upper negative 1.75, mean 0 and standard deviation 1 default values keep as it is. If we enter, we get this value, the left tail probability. For right tail, lower is 1.48, upper is 1E99, very high positive value representing positive infinity, mean 0 and standard deviation 1 keep default values as it is. If we enter, we get this value, the right tail probability. For middle probability, lower is negative 1.42, upper is 0.96, mean 0 and standard deviation 1 default values as it is. If we enter, we get this as the middle probability. In the last step of computing probabilities of standard normal distribution, we consider a traditional method, that is using z-table. This is the z-table. We find this table in most of the statistics book and also online. The first column of this z-table is the z-score value up to the 10th place. The 100th place is at the top row. The probabilities are inside the body of the table. The required probability will be the one that is located at the intersection of the row containing the z-score up to the 10th place and the column corresponding to the second decimal place. Let's start the example considering the left tail probability. That is, probability z-score less than or equal to negative 1.75 using this z-table. Process starts at locating the negative 1.7. here at the first column of the table. Once we locate this value, we shall search the probability at the intersection of this row and containing the column of 0.05. The required probability is 0.04006 is located at the intersection of the row containing negative 1.7 and the column of 0.05. Right tail probability. Probability z-score greater or equal to 1.48. Here, we need to notice that this z-table only lists the area to the left of z-score, but not to the right of z-score. This value here in the table is the left tail area, but we are trying to find the area to the right of z-score. So, we would use the principle of complement of probability. That is, probability g greater than 1.48 equals 1 minus probability g square less or equal to 1.48. That is, probability right tail equals 1 minus probability left tail, which is equals 1 minus this left tail equals to the right tail. The probability value 0.06944 is the right tail probability. Now let's proceed to compute middle probability with this example. Probability G score lying between negative 1.42 to 0.9, which is the area in between negative 1.42 to 0.96 as shown here in this figure. Notice that this interval splits into these two left tail probabilities. First, this z-score less than 0.96 with probability 0.83147 and this z-score less than negative 1.42 with probability 0.07780. That is, the middle probability is the difference of these two left tail probabilities given in this probability expression and computed here as the difference of two left tail probabilities which equals 0.75367 is the middle probability equivalent to this shaded area included in this symbol. Now let's discuss an example of a general normal distribution that we frequently come across in our real life day-to-day activities. Consider this example. The monthly salary of employees working in a factory follows a normal distribution with a mean of $4,500 and a standard deviation of $1,200. This symbolic representation denotes a random variable x follows normal distribution with mean 4,500 and a variance of 1,200 squared. If we randomly select an employee working in the factory, our interest here is to find that the selected employee has salary less than 3,500 per month, left tail probability, salary greater than $6,000 per month, right tail probability, and salary in between $3,800 and $5,600 per month, middle probability. We shall discuss these probabilities in detail using different methods such as Z-table or Excel, TI, and my website link. Among these methods, we experience already my website and this link is the easiest one to start with. Let's get to this page. Here is the page. Select the button normal table manual and change this mean to 4,500 and standard deviation to 1,200. Keep lower tail as it is. Change the lower value as 3,500. Refresh the page.
Observed at the display panel, the shaded area is the left tail probability equals 0.2023. It tells about 20% of employees earn less than $3,500 per month. Change this tail choices to upper and the change upper value to 6,000 and refresh. Here we observe that the shaded area is the right tail probability equals 0.1056. It tells about 11% of employees earn more than $6,000 per month. For the middle probability, select middle on the tail choices and lower value to 3,800 and upper value to 5,600. And we see that here in the display panel, the shaded area is the middle probability equals 0.5405. It tells that about 54% of employees earn in between $3,800 and $5,600 per month. Let's use to R to compute these probabilities. The command is pnorm with argument value, mean, standard deviation, and lower tail equals true. For left tail probabilities, this is pnorm value 3,500, mean 4,500, and standard deviation 1,200. If we copy this command and paste at the R console and enter, we get this value, left tail probability. For right tail, with the same command pnorm, upper value is 6,000, and here we add the last argument lower dot tail equal to false. If we enter, we get this right tail probability. The middle probability is the difference of these two norms, and first is the p norm of 5,600 minus the p norm of 3,800 with the mean 4,500 and a standard deviation of 1,200. If you enter, we get this value as the middle probability. Let's see how we can use Excel to find these probabilities. Command is norm.dist with the argument value, mean, standard deviation, and 2. For left tail probability, we have this command, norm.dist, lower value 3,500, mean 4,500, standard deviation 1,200. If we copy this command and paste in any cell of Excel worksheet, we get this left tail probability. There is no direct command for right tail probability. So we use the principle of complement of probability to find the right tail probability. That is, right tail probability is equal to 1 minus the left tail probability. If we copy this command and paste in any cell of Excel, we get the right tail probability. To find middle tail probability, we take the difference of two left tail probability. Here is the command. If we copy this command and paste to any cell of this Excel worksheet, we get the middle tail probability. Using PI calculator, press two buttons, second and bars on the calculator. That leads you to a next screen that contains menu item. Press 2 normal CDF. You will get to the next screen where you need to supply your information such as lower, upper, mean, and standard deviation. Enter all this information and enter to see the result. For the left tail, second bars, 2 normal CDF, lower is -1E99, very high negative value representing negative infinity. Upper is 3,500, mean 4,500, standard deviation 1,200. If you enter, you get the lower tail probability. For the right tail, second bars,
to normal CDF. Lower is 6,000, upper is 1899, very high positive value, presenting positive infinity, mean 4,500, and deviation 1,200. Enter, you get this as right probability. For middle, second bars to normal CDF, lower is 3,800, upper is 5,600, mean 4,500, and standard deviation 1,200. If you enter these values, you get this, the middle probability. Let's use Z-table to find these probabilities. Before using Z-table, it is mandatory that X values need to be changed to Z-score using this standard transformation. On the left tail, Z-score corresponding to value 3,500 is negative 0.83. Let's try to find the probability Z-score less than negative 0.83 from the table. This is the table, negative 83. So this is the probability 0.20327. Here this is 0.20327. Similarly, we change this value 6,000 to Z-score, which is 1.25. Let's try to see this probability in Z-table. This is the Z-table. The value corresponding to 1.25 is 89435. Here we need to notice that this Z-table has only the left tail probability, not the right tail probability. So we need to use the principle of complement of probability to find the right tail probability. That is, probability Z-score greater than 1.25 is equals 1 minus probability Z less than 1.25. So this value we can get from the table is 0.89435. So the right tail probability is 0.10565. Similarly, for middle probability, we need to convert this 3,800 to Z-score, which is negative 0.58, and corresponding to 5,600, the Z-value is 0.92. Let's try to see the probabilities of these Z-values at the Z-table. The probability corresponding to Z-score negative 0.58 is 0.28096, and value corresponding to 0.92 is 0.82121. So we use this probabilities to find the difference of left tail probabilities. The difference of left tail probabilities 0.82121 minus 0.28096 is 0.54025. This is the middle probability. For detailed reference of this normal distribution, please visit my website at this link www.teachwithmaths.com chapter 6 lecture note hacks. In this video, we discussed in detail how to compute probability of a normal distribution. We understand that the normal distribution gives us a valuable insights into the pattern and behavior of the data set. It allows us to calculate the likelihood of an event within a given range of values and helps predictions.